My name is Kaela Fennell-Chin, and I will be participating in Georgia Tech Challenge 2014.
My problem, which is Math 1000, problem number 8, deals with the application of derivatives. Derivatives can be applied to real-life situations when thinking of how the rate of something is related to the rate of something else. So my problem states the volume of a sphere of radius r is given by the formula v is equal to 4 over 3 pi r to the third. A spherical balloon is being filled by an incompressible gas at a rate of 25 cubic inches per second. And how fast is the radius of the balloon changing when r is 18? From this problem, we have that the v, which is your volume, is going to be equal to 4 over 3 pi r, which is your radius, cubed. And what else we can get from the problem is that the rate at which the volume is increasing is going to be written as dv dr, which is 25. Then the question is asking you how fast is the radius changing. So change of the radius is going to be d dr, which is what we're trying to figure out. Then they tell us we want to find out how much the radius is changing when r is equal to 18. Okay, in order to solve this, we have to take the derivative of this formula right here. In order to take the derivative, we use something called the power rule. So we're going to use power rule. And usually when you take the derivative, we know the normal formula for taking a derivative is the definition of derivative is the limit as delta x approaches 0 of the function f of x plus delta x minus f of x all over delta x. But the power rule simplifies this for us. So all we have to do is, if our function is f of x is equal to, let's say, x to the n, all we're going to do is take down this exponent. So the derivative of x is now going to be n of x to the n minus 1. So if we were to do a simple problem for this, we'd use x to the third. If we were to use the power rule to take the derivative, we'd take down the 3. So it would be 3x, then 3 minus 1, which is 2. So now if we were to apply this power rule to our formula we have over here, we're going to say that the derivative of v with respect to r is going to be, take down the 3, so we have 3 times 4 over 3 pi. The derivative of r is going to be d with respect to dr of r squared, since we subtracted the 1. Now, what we're going to do is we're going to simplify it a bit. So we have dv dr is equal to, those cancel out, 4 pi d dr r squared. And now, since we wrote out what everything was from the beginning, we can start plugging in. So dv dr, they said it was 25. So we're going to put 25 is equal to 4 pi, we're still looking for dr, ddr, and then r 18. So now we're going to solve for ddr, which is just going to be simple algebra. So we're going to have 25 divided by 18 squared is equal to 4 pi d dr. Let's divide by 4. So 25 over 18 squared times 4 is equal to pi d dr. Then we're going to have 25 divided by 18 squared times 4 times pi is equal to d dr. So this is going to be your answer.